Historically, most of the networking used for ML has been proprietary systems or special purpose networks with a background in HPC. We know that Ethernet's been able to displace many application-specific networks. And I think the really interesting question is, can Ethernet do absolutely everything, all the interconnect challenges within the ML workspace? In order to look at whether that is the case, you need to look deep into the actual architecture, because the requirements on the interconnect are very much driven by the characteristics of the nodes themselves. If you look at Google's TPU systems, we use a proprietary network, which we call ICI, but it is actually based even today on the Ethernet PHYs. And the way that we had to, the interesting thing is that the way that we had to expand Ethernet in order to make it usable for what we call the scale-up network is we actually used many of the features which are looking forward to be standardized within Ultra Ethernet. So I think the evidence of our large-scale TPU systems is that potentially we can use Ethernet for scale-up, which is actually the most challenging interconnect use case. Now, other architectures take a different view to how the scale-up network is done. And in particular, if you use a load store or a memory model for that scale-up network, it's much, much, much more latency sensitive. And that's what's driving the need for potentially alternative solutions for that scale-up network. And that's the UA Link Consortium has been founded to address that in a standards-based way. But I think what we can say with some level of confidence is that at least in the scale-out network, and of course, obviously in the host network, Ethernet is the way of the future.